Everyone, I hope everyone's been taken care of. You're all fed, watered, and re-energized, ready for this afternoon. So we're going to take you on a little bit of a journey, how we've implemented artificial intelligence into our factory in Sony, Pencoed, in South Wales. Before we do that, we want to introduce you to something that's helping us absolutely revolutionize how we're enabling to do this. So this is the Sony IMX500 Intelligent Vision Sensor. So the unique part of this, it is a low-cost device, and actually it allows us to deploy artificial intelligence models at the vision sensor itself. So we'll come on to that a little bit later on and see how it falls in. But first of all, I think before we take you on a journey, maybe a little bit about myself and a little bit about Hannah. So my name's Andrew Punton. I've worked with Sony now for just a tad over 28 years. So my background has been everything from CRT development with the television, quality engineering, industrial engineering. I said in more recent years, I've been part of the new business development team, where I have helped companies develop their products from scratch, bring them to market, not necessarily Sony products, but third-party products such as something I know you guys are all probably aware of, like the Raspberry Pi, helping those develop, getting those into sort of scalable manufacturing. And right now where I am today, currently working with headquarters developing AI and items such as this nature.
So hi everyone, I can't quite compete with Andrew's 28 years worth of experience, but I do have 8 years, so that's something. My name's Hannah Williams. My background is project management, procurement in electronics, and I now head up our new business development area for our manufacturing services, our solutions, and I am supporting now our emerging technology side of the business, so hence me joining Andrew today. One thing that we really want to express to you is about how we're adding value within our production environment. And I think that's something for you guys is maybe identifying how this could add value in your areas as well. So I'll give you a little snippet about our company overview, because some of you may have heard of Sony, but do you actually know a little bit more about our Sony UK Technology Centre? Some of you may not. So I'll give you a brief overview. Then we just want to share how we actually built our foundations from manual operations all the way through to automation. And then we'll touch on adoption of AI. So who are we? There's 6 pillars to Sony, covering entertainment, pictures, music, gaming, and we are at the heart of the entertainment and sound division. And within that, we're collaborating right now with our imaging and sensing solutions business. So we're based down in South Wales, about 20 minutes from Cardiff, and we supply the European and the UK market, as well as some of the global market with our Sony products. But just to give you an insight, this is what our factory floor looks like. It's very a complex environment, lots of efficiency and process automation going on, but this is the heart of where we are currently based.
I think something you might actually notice is a lot of people think of a factory, big, huge battleship production lines, end-to-end. This isn't necessarily the case. In some instances, when we're looking at the low-value, high-volume products, such as the Raspberry Pi, and actually when we're manufacturing the Raspberry Pi, recently, we've been building those in sort of a million a month, effectively.
Yeah.
So some real large volumes. And this area you hear is our professional broadcast division. And what you can see here is not those big battleship lines. So the individual operator that you can see here, or team players, as we like to call them, will be building a camera from end to end. We find that we lost efficiency if we have these big battleship lines. When something's waiting there, not actually moving, we are losing time.
Now, I just want to share with you how diverse our portfolio is, and I appreciate it's a little bit of a small slide, so those at the back I will explain. But we are a manufacturing centre of excellence. We manufacture our broadcast and professional cameras as well as peripheral equipment. But one of the key things is we are a collaborative manufacturer, which means we manufacture on behalf of third party. So as Andrew touched on our Raspberry Pi, we make all of the Raspberry Pis down in South Wales, and we've just hit over our 50 millionth. So quite a large-scale operation. But not only that, we're a service provider. We offer our services out across Europe and the UK for all of our Sony equipment, as well as sending engineers out there within industry to healthcare settings, etc., to support our customers. We are also a solutions centre, so we offer lots of internal and external solutions in terms of try before you buy, those kinds of things. And we are home to a business incubation centre. So that's where we are home to tenants in like-minded businesses from network, IT infrastructure, renewable energy spaces. But really today it's all about factory of the future. So delving straight into our smart factory, our IoT, there's a lot of research which is happening, and there's a lot of deployment of AI. So that's really what we want to share with you today. An additional point which is worth noting, how do we actually go about this within our environment? As we know, the whole adoption of AI and the education of that is a new infrastructure, and how do we bring our people with us? Something that's really key to our culture and ethos, and it's embedded actually in our culture, is what we call production innovation. So within Sony UK Technology Centre, we're all known as team players. We're not, well, we are colleagues, but we're not known as just staff. We're all team players working towards one goal. So we give everyone the autonomy to make those changes. What does that actually mean? You can come up with your own ideas to optimize your processes, make things more efficient. You can put those ideas in to remove waste and try and identify, are there opportunities to add value to our organization? And that's something that everyone is involved with. And myself and Andrew are quite passionate about that, because I think to have that autonomy to make change is quite unusual sometimes in certain manufacturing facilities.
I think this is one of the fundamental basics. So as part of our journey, it's actually, why are we touching on this? Because this is the foundation. And what I mean by the foundation is you have to have people in your environment to be able to have catalyst and change. If you want to deploy the likes of AI in your process, you want to have people to accept it. How do you get that people to accept it and adopt it is the likes of this. So production innovation, like Hannah touched on. So we have a bonus scheme. So every person, whether that be our operators, team players, cleaners, all the way up to the MD, effectively, what we will do is take part in one production innovation each year, and that'll be part of a bonus scheme. Therefore, it starts to develop that culture to change. There is not a fear of change. We will start to develop that and continuously grow in it. And what you do tend to sort of grow then, should we say, is that bottom-up approach, where you have team players, operators come and saying, we want to change the process, we've got this idea, we want to fundamentally drive this forward. How can we do it? What tools are available? Then they'll start to engage with the engineers, they start to engage with all of the various departments, and this is where that growth sector starts to sort of grow as a united front, should we say. The other section is touching on your education and communication, and actually thinking again, why are we speaking about this? Actually, what we are doing here is developing grassroots for people for tomorrow. So right now, I think 4 days a week, we will invite schools onto our manufacturing facility. And part of the national curriculum these days with regards to the Raspberry Pi is the coding. So what they will do as part of their visit to Pencoed is they will spend a day in our environment. We will take them through film, and they will get to touch, feel, play with the cameras, make some films. They will get time to go down into our production process. They will get to look how things are manufactured, understand a little bit more about the Raspberry Pi, start to code. Now, these ages groups come from 10 to sort of 15, 16. Now, the beauty of this is why are we doing it? We are now developing the engineers, the leaders of tomorrow. So it's all part of this ecosystem that we're trying to generate. Complete change, maybe what you don't generally think of as a manufacturing environment. And for the years that I've been here, I've seen people who've come there as like the 14, 15-year-olds. Then they've come back and maybe a summer job with us and sort of understand a little bit more. And right now, some of those people have become apprentices and are engineers. They are the managers of tomorrow. So it's really nice to see from that front.
I think over the years, actually, I think we've had about 28,000 school children which have come through our doors. So hopefully that continues now as we develop. I appreciate that's a snippet of our company overview. We could talk to you for hours about that. But we just want to start by sharing how we actually built our foundations going from the manual operations. So Andrew's going to take you through that, because as you know, he's been there 28 years. He knows a little far more than me.
I don't know tell you where you were born at that point, can you? Okay, so as part of that foundation, let's rewind the clock back. So we're looking back there to some of the industrial resolutions. So Industry 1, mechanization. Let's fast forward to where we are today, Industry 4. Now, a lot of people will be saying, well, actually, we're 4.5 or 5. Actually, if we take a step back and think, are we actually doing all that we need to be doing to say, yeah, we've hit digitalization? I think some aspects, you're going to really say, being honest with yourselves, no, we're not quite there yet. So we must nail that, and that becomes the driver for this and the personalization of where we all aim to go collectively. So how are we doing that? Us as a manufacturing site, and yes, we are a blue chip company, but as a blue chip company in Sony, everyone thinks we've got millions, and we can throw all sorts of obscene money at all these different trials and AI products, and if they fail, it doesn't really matter. Actually, we have to be a bit of a standalone. So to give a bit of a sense check, so when I started in Sony those years ago, there was 4,000 people working there. And that was great, fantastic. Then the CRT business went, like everybody knows, things change. We went from 4,000 people down to 250. At that point, we had to reinvent ourselves. We had to find a way of stabilizing what we wanted to do. And actually, if we wanted to stay there, we had to do something completely different. We had to challenge ourselves to do something better today than we did yesterday. So using some of the enabling technologies of where we are now, we're looking at performance by analysis and AI. So we have access, like I mentioned just now, to some of the image and sensing fusion, edge AI, cloud analytics, and big data infrastructure. So we tried to break these down into 3 use cases. We've broken those down into product, process, and people. So product, I think everybody here can relate to quite simply, that it's how we can identify those quality inspections, variations, alerts, product tracking, historian. That's the basic level. Some of the bit more challenging ones is integration. So as you can see here, we've got some of the collaborative robots building products within our facility. We're always looking for that low-cost solution. Actually, if we want to deploy it on something that's high value, low volume, actually is the return of investment there. So we need something that we can deploy quickly, swiftly, and is cost efficient. It needs to be secure and with regards to monitoring control, and actually legacy equipment compatible. So we don't want to go and spend another £500,000 on the latest surface mount technology machine that has AI capability. We want something we could retrofit to it and actually make things a little bit more sustainable. And one of the challenging sectors is people. And how do we respectfully monitor these non-intrusively? So something we'll touch on in some of the use cases. We'll show you a couple of videos later. And again, getting the buy-in from the people and getting them used to the change, that's a key fundamental around this as well. So as I mentioned, we actually manufacture the Raspberry Pi. The levels we started at many, many years ago, they are nowhere near what we are now. But we were lucky enough to pitch for this business, and it was something we managed to repatriate back from the Far East to be cost competitive. When we brought that business back, this is effectively what it looked like. And you look at that from any standpoint from business, it is labor intense. There is a lot of individual people up there, and to break it down, we had 17 operators per line, 3 lines, 2 shifts, 102 operators. That is a lot of cost. Now, when we say we're going to move from this to making it more efficient, a lot of people are thinking, actually, what are you going to do? You're going to cut, you're going to lose your jobs. No, we've got to be sustainable. So how do we grow our business sustainably? So what we look to do is all these operators here, we want to keep them. They're highly skilled. They spend a lot of time, they understand our process, and now we've been developing these people to be key drivers and leaders and sponsors with regards to production innovation. So we want to keep them. So how do we develop these and put them on that continuous Ferris wheel of a new business generation? Let's get a new business in. Let's deploy these people on it. Let's help them to help themselves to develop our business. So what's that process look like now? Completely different. Yes, we've needed to go to the automation side of things. And this is like how we've developed it through the Industry 4.0 sector. So that front section there, we've got collaborative robots. So they fit in all the, let's say, Ethernets. They are fit in the HDMI connectors. So we've managed to be able to do that. Now, this is for us to be cost beneficial. So 6 operators per line, 3 lines, 2 shifts, 36 operators. This actual sort of, if you want for a bit of a revolution for us, I think this saved us on an annual basis, straight away off the top of my head, about £1.5 to £2 million in that year. So by doing this, I think our ROI was around 6 months. And the reason it was 6 months, because a lot of the stuff we'd done here, apart from buying the ABB robots, was something we designed, developed, manufactured ourselves. We wanted to make change. This was that change that I spoke of. I know I keep on coming back to it, but it's key for us now we drive things forward.
So in terms of that particular journey, we've gone from manual, we've then introduced some co-robotics, some bespoke automation, but for us it's about how do we get to that next step further. So this is all about the adoption of AI, which is kind of where we're developing even further right now. So Andrew touched on right at the very start in relation to IMX 500, the world's first intelligent vision sensor. And I won't go through all of the benefits, but this is really where it's adding value to our organization. And one of the key things is about the AI processing, which is being done actually on the vision sensor itself, which is something which is really key in terms of what Andrew is exploring about how we deploy that in certain areas of our factory.
Okay, so how we've been looking to adopt the edge and AI within our manufacturing process. So we are now trying to turn our factory into a showcase factory. It's not just a case of demonstrating AI for the case of improving our manufacturing facilities, but it's for people to understand how they can sort of export it into their various industries. You know, could it work in construction? Could it work in food and drink? It's not just the manufacturer. We're not trying to be insular around it. So in this instance, we've tried to break it down into 3 simple sectors: smart safety, smart automation, and smart assistance. So how does this roadmap begin to structure itself? So key fundamental for us is define a clear use case. So understand what it is not, and what do you want success to look like. You know, use the likes of Demake and different things that you have in your toolbox to be able to do this. Then we're looking to create that initial first stage AI model. So on this one, we will develop a number of maybe real-life pictures that we'll actually deploy on something like a brain builder such as Neurala. Then the next stage is how do we package that AI? We need to package that AI model onto the device itself. And we use that currently using the Sony product, which is Sony Itrios packaging process. Then we need to capture and visualize the data. Now, this is key. When we're looking at the items of Cumulocity around here, this is how we get those visual display dashboards. This is how you grow your business. This is how you make it far more beneficial, cost-effective, and this is where you save the money and grow. Then we need to validate it. Now, this is a key fundamental challenge. So when I mean validation, so we've got our AI model out there. Our engineers trust, believe in it. They want to get it running. Now we're capturing the data. Now, one point where you could lose a lot of people is once they start thinking the data that they're getting isn't actual fact. If they don't believe it, they start to lose trust in the entirety of the process. And that's what you've got to gain. So this is a key step of nailing. So what I mean by that is we've got our AI model out there, we've got it running. So how do we understand if it is doing what it says on the tin, so to speak? So in some instances, we will deploy a real-life camera. We will run it in real time. We can go back and look over that footage. So let's say, for argument's sake, we're looking at somebody lifting a box. We want to understand if that person is lifting the box and how do we improve our model continuously. So we can go back and look at that model, and then once we believe we've got it nailed, that's part of a validation. And when we launch it into that production process, people will actually trust that data. And then what do we do with the data? Fundamentally, when you start on this, you'll have a lot of people who will want to revert back to pen and paper. They will want to go back to the spreadsheets. They don't necessarily want to look at the dashboards, but once they find out the benefits of doing it, how efficient it is, how much it saves them, then your business really, really grows.
Now, taking those 6 key steps in mind, how have we actually applied that within our environment? So we're going to take you through just 4 examples covering the smart safety and then the smart assistance. So this particular use case starts with about identifying adherence to personal protection equipment. And this is really important because we've got very complex machines, hazardous environments, and this could potentially be where it could add value in some of your environments potentially.
So when we look at this, yes, it's a solder bath. There's some very, very hot temperatures there. There's molten solder in there, and injury is available. And you can see right here, apart from that bit of guarding, it can happen. It can happen very, very quickly. What we're going to try and do is we're going to try and help and support and educate the people first. This is the first stage for it. So right now, we want to understand if the people who are working in that area are wearing the correct PPE, that's the personal protection equipment. And you can see here, using this basic model, it is picking up gloves. This is a very early stage one, and you can see the percentage of what is picking up is low. Right now, we've got that around about 95, 98% to identifying if it is correct PP or not. Now, this has to work through various areas. You have to run it through different ethnic groups to make sure it's fundamentally what it says on the tin and deliver it as it needs to be. So what I'm going to actually do is show you of how this currently looks at present. So this hatched area here, the yellow and black, once somebody comes past there, being actually non-compliant, it highlights it. Now this will actually collect that data, put it on a dashboard. It allows us then to create an alarm. It brings everyone's attention to that area. Something is not right. Actually, is it stopping everything 100%? At this point, no. We're starting to understand. But what we can do is go back and we can re-educate people. So this information can be readily available to our team players. There is a live dashboard using the Cumulocity on the screen, right by the side of our solder bath. In our team leaders, our managers, our health and safety departments, they will have access to these various dashboards, and they can understand if people are being compliant or not. Therefore, they can know that they can come down and re-educate individuals around this. So some of the key factors of supporting this. Now, maybe the next key stage from this is to take it to a more profound way of preventing any injury. So could we actually use the AI camera Now we know that it can identify if somebody's wearing the correct PPE to lock or unlock that solder bath. So if somebody comes there with a key, they know they're competent people, they left their tool in there. They want to just collect their tool. They know they've done this, thousands of times, it's never really an issue. That one time could be a problem. But what we could look to do is, they put the key in, they go to turn it. Actually, it's on sort of an interlock, and that interlock, using the AI, will say, actually, yes, they've got the key, they've got access to us, but they're not wearing the face mask, they're not wearing the gloves, they're not wearing the sleeves. Do not open. It forces that change. So that's how we use an AI in some of the areas. And this would be like the typical dashboard that we'd have, which would be trying to break it down to be really simplistic at the edge of our solder bath. So we'd understand the total safe situations, the day total unsafe, very simple, when it's happened, what percentage, and more importantly, is it a case of somebody's maliciously gone up there and just tried to open the solder bath wearing it? No, we can start to understand the metadata around it. So are they not wearing gloves? Are they not wearing a visor correctly? Is there no PPE at all? So we start to understand this, and this is what allows us to sort of categorize all these individual areas and change the process.
So staying on the same theme with smart safety, another adherence which we're trying to identify is posture gesture when performing manual handling tasks. And this really adds value because this is to ensure that people are actually conducting those tasks in the right manner.
Yeah. So with regards to pose gesture, now there's two ways of looking at this. The first way is, in our heart of hearts, we want to look after the welfare of all the individual operators and people who work for us. That is key. So if we have a means of telling, educating them that they are lifting that box correctly, that is fantastic. However, I'm pretty sure many of you people here have been in corporations for many, many years, and you have had people who have left the company maybe 5 years, 10 years, and all of a sudden there's a claim come in for a back injury, an injury of some means. However, we can't do anything that's happened in the past, but actually we're fundamentally making a change that from this point on, we can educate people to make sure that they are lifting the box correctly. If not, we are educating them very, very quickly to improve that process. Then I'm pretty sure the likes of insurance companies then are going to want to buy into this type of thing and saying, actually, you're proving everything in the right way and you're eliminating challenges of that nature. So what does that process look like? So as you can see here, the operator comes in. Now the way the pose gesture currently works is calculating the angles that the legs are bent and the gesture of the back. So what is a good lift? What is a bad lift? Now this is live, and I think probably one of the questions that you've got is, actually, with regards to the AI and the GDPR, is this really an issue? So many people have had challenges when you're processing the AI, especially on the likes of the cloud, it becomes a challenge. Now, one of the key factors around the IMX 500 device is, because we're processing the raw data, the vision sensor itself, we are only sending metadata to the cloud. Therefore, it negates the challenges that you might have around the GDPR. So, luck more than judgment in some of the instances like that, it actually gives us a loophole in it all. But it really works.
Now, moving slightly on to our smart assistants, how are we applying this? So this is all about detecting the correct placement of wire harnesses. Now, we did identify that when there are activities which are going on, whether there's kind of repairs or we're trying to modify those cables can be put into the incorrect places. Yeah.
So this is a very simplistic classification model. So as you can see on the left-hand side, what we want it to be every single time is blue, black, red. Actually, if anybody wires it any other way, actually you can detect what it is, what the problem is, very, very simplistic. So one of our customers actually based out in Japan was actually, can we take us a step further? And we wanted to challenge ourselves, like I said, do something better today than we did yesterday. So what we've tried to look at is something of this nature, something that some of you might have come across. So when we have a circuit board, now these are all like hand-wired mods to some extent. You have to go to a certain location, whether that be a resistor capacitor, a certain land on that circuit board, and they have to be a specific color, length, and we know that's all joining. So this is a very simplistic, standalone AI mod that we've used using the IMX at the moment, and we can collect the relevant data on the dashboard. The key thing about this is, because there's a battery in it, it's suddenly portable. Now, this you can move around your facility, and if you're training somebody new, this helps to ensure that whatever they're building it right first time, every time. If not, they know they built it incorrectly. Now, this was a challenge. So you can imagine when you're building an AI model, it looks great when you're looking at the same product in the same place every single time. But you can see now we're actually manipulating these wires. So larger different models and a lot more time spent in it. But we've had the capability of being able to understand if somebody moves those, because it could be effectively not far off an infinite amount of movement between each of those wires. And each time it is picking up correctly or not. Now, when you look at this, yes, we've had some software engineers on it, and we've tried to make this as simplistic as possible to actually build the AI models on. But this, what you're seeing here, from a discussion that we had with the team in Japan, within 2 weeks, we designed, developed, and that is fully functional at a level that you can see here. So when you think of that, actually it's quite simplistic and low cost as well.
And just touching on our last use case to share with you today is still on the smart assistance theme, but it's all about our test pods machines. So basically we have a number of circuit boards which feed into these machines, but how do we know that that actual operation is running as efficiently as possible?
So in this one, we'll actually call it in a classification of heat mapping. So each one of these individual lines feeds a test pod. That test pod individually tests that circuit board. So what we want to do is improve the efficiency of the process, excuse me, and measure the efficiency of the process. And what are we actually doing here? So actually running the model live, it identifies what boards have gone in each lane. And you can see this is actually physically fed by 2 individual people. So once we deploy this model, one of the key fundamentals we found very, very quickly is that if somebody was left-handed, they'd naturally favor lane 1 and lane 2. If somebody was right-handed, it naturally favour lane 3 and lane 4. So depending on who you add on there, all of a sudden, you're potentially starving the machines. So the first time that we were seeing this in our manufacturing environment was the team leaders were saying, actually, going to the production engineering team and saying, hi guys, we haven't hit target today, we're 2% down, and the reason is your pods that you have designed, developed, and you are maintaining are not functioning correctly. So they would continuously have the blame. And in actual fact, it was being starved of product because of the means that we've just said. So what we've implemented in this process now is the next stage. So there's individual lights on there. So if somebody is left or right-handed, we can identify and tell them where to put it. This is a very simple use case of the AI. So the next stage of this is we have a pick-and-place robot. A pick-and-place robot that can pick and place those individual areas and know it's feeding each an individual pod as most efficiently as possible. So I think it's a bit of a roundup, a bit of a top level of some of the use cases we've been developing. I hope it's been of some insight to you. But where we are right now, so we have been developing the IMX and obviously the use case, like we said here. Actually, we're not here to sort of sell a solution. What we're trying to find at the moment is people, such as yourselves, who could be effectively end users, who would like to adopt the likes of AI, and look to sort of do this along with the Cumulocity and the IMX 500s within your process. Or effectively, you could be the likes of system integrators that could help us to scale this business and get to deploy it and get to change things in your industry as well. So if you do have any questions, I'm sure everybody will be at the Guinness factory tonight, I'm pretty sure, and it'd be great to share a beer with you. And I've been Andrew Punton.
And I'm Hannah Williams.
And please get in touch with us.
Thank you.
Thank you very much.
I think we have a few minutes if we can take some questions now. Any questions?
You mentioned it's pretty low cost. What's
Yeah.
more or less the price for...
So if I was to look back at the actual camera that we've got here, we were talking around $350. So when you're looking at that, we know at Vision Systems, so when I've had some discussions with Vision Systems around collaborative robots, they say it's a minimum of 10 grand. Now, actually that 10 grand is a huge cost. We're talking a lot less. Yes, it's more developing it from your own point of view, but you imagine now, it's not a case of we're identifying a problem. With the likes of Cumulocity, we're actually identifying a problem, tell you and be able to categorize it, how you could plan your total planned maintenance. So it's even better at that lower cost. And something that is going on at the moment, I think it's going to be sort of announced this week, is we've been collaborating with the likes of Raspberry Pi, and we're looking to launch another low-cost version of a Raspberry Pi with an IMX 500 mounted on it as well. But all dates not to be confirmed.
One other question, do you aim mainly for the industry market or also private market? Because I think an AI camera could be also useful for home automatization, like license plate recognition for the gateway at the driveway, yeah?
Yeah, absolutely. And I think one of the key fundamentals is, yes, there's that industrial version of it, and I think we're going to capitalize on that. So we're driving that with some other cameras, the Triton camera, which we're developing as well, as that's far more industrialized. But when we're talking about the Raspberry Pi IMX, that is far more suited. So we've got that industry version and obviously the hobbyist type thing, so we can do the top-down and bottom-up approach. And one thing that we're trying to develop as well as part of this and the iTrust platform is a marketplace. So if you go away, like you personally, like yourself, and you develop something on the AMPR system that wants to have access into your own house, you could upload that onto Marketplace effectively. And if somebody else wanted to sort of go in and buy that, say, actually, somebody's done all the hard lead work, I can go there, I can purchase it, you will potentially get some revenue for yourself. So that's how we're trying to build and develop those model zoos as well.
Thank you.
No problem.
Thank you for a really interesting presentation. How do you actually deploy it? Is that, do you stream the, if I understood correctly, you actually do all of the ML models and you deploy them next to the sensor, or can you please share how, from technical perspective, how it works?
Okay, so from, try to keep it basic. Obviously, I'm not that software engineer. My background is mechanical, but where we are right now is that we will take a number of photographs. So we've got two ways of doing this to develop that model. We will take maybe 100, 200, 300 photographs of that circuit board if we're doing classification model. We would then put that onto Neurala, onto the brain builder. That would go and be packaged on the vision sensor itself. So that's where the AI mod would sit. And then when you extrapolate the data and visualize it, that's where it goes on to Cumulocity. However, one of the key factors we found as well on that front is how can we improve the speed of it? So if we want to take 1,000 photos, 10,000 photos, 100,000 photos, that becomes extremely time consuming. So what we've been doing is a couple of the guys, obviously, because we're a broadcast professional camera and we have some media experts with us, we've been using some of the CAD designers as well. And we've been using the likes of Blender and Unreal Engine to do computer-generated models of this. So, okay, we haven't shown it here, but imagine if you like a actual cardboard box that has a friction feeder, and that friction feeder every 3 seconds will place a manual into that box. So what we want to do is identify that going into the box. So when it actually fits in the box, you take that photo, initial photo, then you have to capture the next one every 3 seconds. But using the Unreal Engine and computer-generated images, you could imagine you've got that little rectangle in the box, and you could get that to sort of run a very simplistic program, and you'd get, I think it's like 300 to 500 images every 2 to 3 seconds. So all of a sudden, your images that you get in there and the time you actually spend in developing your model then is far, far quicker. So those are the type of things that we use in our toolbox at the moment.
Is the development lifecycle management a problem for you, or have you all figured that?
I think everything from that nature is constantly growing and changing day to day as well. So, you know, development lifecycle and different things like that. We're implementing everything out there. We're understanding more about it each day. And like I say, this is, you know, the first stage of a big journey for us. So, hope that answers.
I have 10 more questions, but we'll catch up.
Maybe over a beer tonight, yeah. Thank you.
Any final questions? In that case, thank you very much, Andrew and Hannah.
Thank you very much.
Thank
everyone.
you.
Okay.